Solo. Oh no, my camera's. You can hear me though, right? You can hear me, but my camera has crashed again. Give me a second. I'm going to fix the camera. Stupid camera. You are not having the greatest night, are you? Oh, poor camera. What do I got to do? I got to end the process. I should ask my security friends if it's considered harmful. Okay, so there it is. Sparko Cam, you're the worst. Yet I love you because you do so much good for my channel. Oh, people who watch this back are probably going to love that. Oh, hello, I'm here for real now. Yay. Okay. Woo. So let's see. What have I done? I've made a few images. I've made some notes for the week. And we're ready to. Oh, somebody's watching. Am I just watching myself, or is somebody here for real? Anyways, doesn't matter. I'm going through the show either way. If you are here for real, then thank you. Oh no, you're already gone. Don't worry about it. That's cool. So this week's chapters, we have two. We've got chapter 17, which is called boundaries, drawing lines. And the point of that chapter is, so we've already talked about components in the past. We've already talked about objects. We started with classes and objects and breaking those objects into sort of modules within a system. And then the next step from there is we talk about moving into components, which is kind of like saying it's groups of modules, and then architectures are how we relate the entire system together, I suppose. And getting back to boundaries and drawing lines, a lot of this feels to be a reiteration of what we've already spoken about, what we talked about in week the week that we did chapter 14 in the component coupling week. We had a lot of I thought, really great detail about how to put that stuff together. So as much as I've gone through and I've recreated not all of the images that came along with this week's content, it just isn't, there isn't enough here for a lot of it that's super new. So I'm going ahead and I'm just trying to cut this down. In fact, I suspect that all of this preamble is. No, I'm only a minute in, so that's not really going to take longer than the entire show today. But we're going to go we're going to go pretty quick with this one. So let's get started now. We want to start by recalling that the purpose of architecture, also known as system design, which you would find in a system design interview, all of those things are around minimizing the human resources cost of changing the system. So the better our architecture is, the easier it is for someone to understand it, for somebody even coming from externally to come in and understand it, to find what they're looking for, and to be able to make changes to the system with confidence. And all of those things, remember, the maintenance of a system is sort of divided into the sections of what we call spelunking, which is, you put on your climbing hat and your forehead lamp, and you get your pickaxe and everything, and you go deep dive into a cave, and there's stalactites and stalagmites, and it's very scary in there, right? And so the metaphor that going into code that you don't understand, trying to understand it, calling that spelunking, is like saying, We don't know what's down there. We don't know how to make the changes that we're being asked for. All of that goes together to say, what is the cost of working with the system? So you go into these dark caves and you don't know what you're going to find. You don't know how to get there. Better architecture is like saying, let's reduce the cost of doing that spelunking. And the other one is the cost of the things that you don't know, the cost of unintended consequences. Strong architecture, strong system design is about creating the conditions where you are likely to minimize the possibility of unintended consequences, things that went wrong because of things that you didn't predict. So that's the story. Now, the process of coupling is recognized as a cost in this chapter in terms of writing all of your code in one place and having it reference each other directly rather than writing your interfaces to find ways to separate the code apart. Now, the next thing that happens within this chapter, the author tells two stories about his experiences through time, going through industry, and the first one is a cautionary tale around drawing boundaries too soon and too deeply, I think might be the word. So he talks about a highfalutin, highly paid and sort of well-respected authoritarian, maybe architect who comes in and dictates the architecture before they even start writing a line of code. The architect comes in and says, well, we've got this thing that we want to do. It's going to be an online system, so we're going to have a GUI layer, a front end layer, where we set up interfaces to work with the intermediate layer, and then there's a scalability layer. And so it's this three-tiered architecture that they're talking about. And they're doing this three-tiered architecture, and there are interfaces and duplications of all of the data models. So your data objects that get passed from one system to the next are all duplicated throughout that chain of elements. And well, while they were developing, they said, well, it's really expensive to run this kind of thing on three computers, and that's only going to happen eventually. But while we're developing it, we're going to build this system intended to run in three computers on one computer. And so they would fire up their multiple systems on one computer and they would run it and develop it. But the cost of developing it was they had to do so much extra code to do it. It was high complexity. It was really hard to understand. There were lots of unintended consequences. And the project, I mean, I don't know if I paid close enough attention, but for the sake of argument, the project failed because they just over-engineered it. And so the first story is a cautionary tale to not take these things that are being said as, what is the word? Don't take these things as gospel. Don't take these things as hard rules. Part of the critical job that we face as software engineering designers and architects is we have to understand that every one of these rules that we talk about is a trade-off. So by doing it one way, we are necessarily not doing it another way, and we are incurring costs versus we are potentially incurring costs now instead of incurring costs later. So again, the warning: over-engineering, bad. Do these things, but try and use your best judgment to know when is the right time to do them and when is not. So there's the first story. Now, the second story I actually quite liked. I thought it was a really great illustration of the whole idea of the reason that we try and defer decisions for as long as we possibly can, what we do when we defer decisions, and how we go about that. So he told a story of when he was writing a software system, and on day one, they said, we know that this software system is going to have a database storage layer. It's probably going to be MySQL. Really important, absolutely critical, but, well, there's only two of us working on the project, and we don't need to develop that database layer right now. We can just sort of stub out the functions. And so the functions would maybe return empty data, not empty data, but sort of JSON packets of data come in when you call this service, and they're just hard coded, and you can still do all of your work. And he says, and then 3 to 6 months went along, and we got to the point where we said, well, now we have to start testing the functionality to, and they called it wiki pages, and so you can imagine how Wikipedia pages work. So they have to be able to write the data, they have to store the data, and then once it's written, they have to be able to retrieve the data. And for the purposes of testing, they took this thing that they stubbed out earlier and they turned it into an interface, and then they implemented this interface in something that they called an in-memory wiki page. Now, that means that while they fire up their system, the in-memory wiki page will handle all of these things like save the data and write the data and retrieve the data. And so they can figure out and prove that their system works. And they say, oh, all of these buttons are working the way they need them. But in terms of testing, it's a very short-lived system, and they're not worried about that yet. And that ran, he says, and that ran us through for another 6 or 7 months. And it was pretty good. And we got that far. And so we got to a year on, and we say, well, now we need to save the data. We need to persist, not save the data, but persist the data. So when they persist the data, they said, oh, the database stuff, we don't really need that. We can just work on text files. And so they re-implemented that interface in something that instead of saving to memory, it saved to text files. And what happened? Well, they got all the way to the end of their version 1.0, their MVP, their go live, and they said, well, this is good enough. It just writes to files. Who cares? Let's start selling it now. And they did. And they had clients, they had customers. And he says, I'm making up the numbers because I didn't read it that closely, but for sake of argument, it's cruising along for a whole year, right? So it's cruising along for a whole year on text files. And they get a customer who comes to them and says, well, I would love to buy your software, but my boss says it's got to be in a MySQL database. And they tell the story that they said, well, that's cool. We're not going to do that for you, but this is how the interface works. You just go ahead and write your own layer and then go ahead and use it. And the story goes that the person who contacted them got back to them in a day, said, yeah, I wrote it myself. That's cool. We'll do that. And then he says, and in a couple of weeks or a couple of months, they said, oh yeah, we stopped using the MySQL. We just didn't need it. It was, it worked fine with flat files. Everybody was happy. Nothing to worry about. We all moved on with our day, and everyone was happy. And that's not to say I don't have some concerns about the security of a system that writes user. Anyways, that's not important, but like you think about the security of that, and does that mean you're storing passwords in plain text? Like, are you, anyways, that's a tangent that I had not originally planned on. I only just thought of that. But anyway, so those are some stories about, excuse me, the goal of architecture is not just to defer your decisions. So he says this is our decision deferral worked out for the best in this case, and then the other one, we made all our decisions early and it screwed us. And And I guess the point of this system is we sort of say we've got to walk the fine line between which one we choose, or maybe he's saying that we actually just choose the defer decisions ones. So there you go. That's, excuse me. That was a big cough building there. Now, so where am I in the story? So that's it. That's everything so far. And after we get through a couple of these stories, we ask the questions, well, where do we draw the lines between systems? And when do we draw them? And what, how do we go about making these decisions? And he comes back and he says, the rule for drawing lines is what you do is you draw the lines between the things that do matter and the things that don't matter. And, well, sure, that's kind of trite, isn't it? Well, so what matters? Well, I believe we talked about it in another chapter, or let me quickly scan ahead. We might have it. Actually, it's coming up. It's actually coming up in a future chapter. How do we decide what is important? Okay, so for now, I'm going to leave it for another week before we talk about how do we know what does matter and what doesn't. Suffice it to say that at this time, we can assume that business rules matter, specific technologies do not. And we'll get into much more detail next week about what business rules are. So don't ask. And for all of you that aren't watching, don't ask. Or, ask, because I would love to know if you're actually watching this at any point. Like and subscribe. So, right. So things that don't matter are said to be like the specific technologies. It doesn't matter if you choose. And the first story was a good illustration of that, right? It doesn't matter if you choose an in-memory database or a flat file database of text files or a MySQL database, or if you go with MongoDB, or if you go with Cassandra or Postgres or SQL Server, except to the extent that it supports your use cases, right? So a flat file database on Facebook is not necessarily going to be performant enough to run a functional system. So here we go. I'm going to switch over to desktop mode. Our files are lining up okay there. So this is one of the diagrams that we can see in the book. And he says, so because we want to draw these boundary lines between the business rules and the things that don't matter, we want to make sure that we design things in a way that is one where the business rules are protected from the business rules being the thing that matters, is protected from the database layer, which does not matter specifically. And so this implementation, so the business rules, because it knows that it needs to it needs to create records, update records, remove records, and geez, why do I always forget what CRUD is? Create, update, like remove and delete are the same, and so what am I? Oh, who's that? Brooklyn! Oh my God! It's so nice to see you. I hope you are very well. You are also looking very good right now too. Here, let me bring you up on screen because I have a photo right now. You are a little purple face right there. Very, very honestly, have you changed your makeup? I think you're positively glowing. I love it. Anyways, yeah, thank you for stopping by. Um, this can't be terribly interesting for you, Brooklyn. I, I mean, this is this is some pretty technical, deep computer stuff. Um, so thank you for being supportive and wonderful. Oh, I'm looking at you. I see. I'm looking at you because you're the chat, and I'm not looking at the camera. Um, but there you go. That's the story. Anyways, thank you for coming along and being supportive. You are currently the only person in chat. So even across all platforms, because I'm streaming on like 5 or 6 platforms. Anyways, back to the story. Back to the story. So the business rules publish an interface, which is like a menu of items which need to be fulfilled in in order for the database access layer. So the database access layer, so the business rules are not aware of the database layer, but it will say effectively, this is the list of things I need you to give me, and the database access layer is the place where we say, let's implement all of the things that the interface layer is requiring of us. And that's how that one goes together. Now, these can both be collapsed down and sort of abstracted even further away. So, right, so we say the business rules are separated from the database information layer and stuff, but we but the business rules are not aware or affected by the database layer, and that's the way it should be. So one day, if we wanted to change the specific database we were using, we could we could just write a new database, and it might not be easy, but it would be easier than trying to it would be easier and less dangerous than trying to change it if it was tightly coupled within the business rules. So that's how we do. And similarly, he goes on to say, well, the GUI, the graphical user interface, the front end, the place where you have the buttons that you click, all of that, that could all be separated off into its own place, because a business rule, such as if we're on Twitch, such as when I click the start streaming button, the business rule fires to say start sending out the live stream to people, right? So it's this is the button, and it fires off the rule, which is start streaming. Now, that's to say that if you're doing that, you could fully rewrite the front end of Twitch, or the visual layer that you see, without affecting the way things behave. And that means you can feel safer and more secure when you're updating the system. Now, so finally, what that means is all of our systems can be laid around in effectively we're talking about concentric circles. You know, our business rules are at the very center, and they change very infrequently, and any sort of chaos and they are the most stable, so any sort of chaos going around on the periphery of the system that we're designing is not going to negatively impact our business's ability to make money, or our software's ability to do the job it has to do. But effectively, those are the same thing. Anyways, so here we go. That's about it for the images, I think. So we can just go back to my looking good face, to quote Brooklyn Doran, who is absolutely correct. Maybe. I'm so cheeky. So now, with that, and again, if you want to change all of these systems, it might not be trivial, but it is considered possible, and it is considered safe. It is far safer to do something like that if we go on. So the next part that we get to in the chapters or in the book here is we start talking about something called plugin architecture, and using these interfaces and these separations of systems says it allows us to have a system where third-party developers or anyone can just add things to our system by calling into an interface, right? So we write this interface, and a really good example, I'm sort of fine-tuning it to be a bit more modern compared to the book. I guess we go back to desktop view. We'd look at something like Visual Studio Code. And I can close that, don't save. And I can close that, don't save, because we're not actually working on real stuff here. Now, if you look at something like extensions within Visual Studio Code, you can see that, what do we have? We have, a GitHub pull requests. We've got C sharp language extensions. But each of these things are completely, here's Grammarly, right? Grammarly is a plugin. So if you think about Grammarly as you might have this as a plugin for Chrome, you might have this as a plugin for Visual Studio Code, and GitLens, Docker, LiveShare, all of these things are plugins. And if you think about it, the team at Visual Studio Code have written their application in such a way, we don't need to keep looking at this, they've written their application in such a way where they can effectively remote disable all plugins or any individual plugin by updating and sending out a new message, sending out a new version of the code, and all the old stuff would stop working. It's because the system of Visual Studio Code itself is fully protected from the plugins, which are considered separate. And so it is very much an asymmetric relationship between the two systems. But when we are designing software systems, that's what we actually want. We want to protect the most important piece, the business critical piece of a software package like Visual Studio Code is you're able to write and edit text. Grammarly, Docker, C# text extensions, or any other, or if you're a React developer, sort of React IntelliSense information, if you are, that's not the core business case, right? So none of these extensions can break the core business rule, which is I'm able to open and edit text files, but they're allowed to come along and enhance that experience. So that's a description of plugin architecture. It's a description of why we want to be able to separate these things apart, not just for writing plugins or allowing for third parties to plug into our stuff, but for our own systems internally within the business of software engineering, because once you have these boundaries designed, you can have other teams of software engineers working on these things in parallel. And if there's a bug over on team 1, it's not going to cause a bug on team 2, team 3, or in the central shared business logic or the business systems. So that's all around reducing the human resources cost of designing software systems. So I'm just going to look at my notes, see if I covered everything, which piece is in charge. We know that it's VS Code. this level of isolation is something that we want. And so here in the conclusions, number one, this is effectively a repeat of the single responsibility principle, which we talked about 2 or 3 weeks ago, something like that, 2 weeks ago. And in order to be able to draw boundaries, which I have another typo right there, we need to be able to partition our system into components. And we talk a little bit more about how do we make those decisions later on, and we've talked a bit already about it. So that's really chapter 17. So moving, and how'd I do? 28 minutes ish with a nice little pause with a hello from Brooklyn. That felt so nice. So thank you. If you are still lurking, it was really lovely to have you stop by and say hello. I really appreciated it, and it made my night. So the next chapter, chapter 18, is the title of the chapter is Boundary Anatomy. We're talking about how do we just, if we just accept that at a later date we learn how to make the decisions about what to portion out, and we have already talked about that once before, then this thing about boundary anatomy is about talking about the types of boundaries we can have, as well as the cost of each type of boundary crossing. So this is a really short bit. We're gonna be done before 9 o'clock. So that's good, so crossing boundary lines. What does it mean to cross a boundary? So we've got our two components, and crossing a boundary is as simple as one function calling a function in another component. And so anytime you send a message from one system to another, that's considered one discrete system. That's considered crossing a boundary. Now, the cost of crossing a boundary can be super low. If you are working in something called a DLL on a Windows machine, so something a dynamic linked library, or in Java, if you are working across jar files, and in Ruby, if you're calling into gems, in Node.js, if you are calling into a node module, those are not expensive. They are as expensive as, to my understanding, as somebody might come in and correct me here, but they are relatively as expensive as calling a function within your own system. But they are broken out because they are separately deployed and they are separately developed systems. But they are effectively free in terms of the cost in calling them. Boundaries, now within a monolith code base, you still do have boundaries, and that can be when you separate your classes out or you call into various modules from different places. So again, if you're looking at node modules, calling, if your function calls into one node module and then into another node module, those are crossing boundaries in its own way, and you can deal with that. So boundaries still exist, but they might not be visible to the end user, and that's just not really important. They can be compiled down into a single package, and you may never have to see it. Now, the next level of this stuff. Which is, you have something called local processes, and the local processes are like when you spin up a second exe in Windows or a second application in Mac, Linux, and everything else. So the discrete difference between processes and system, and the previous just sort of local DLL files is by starting up a new process, you have no memory access from one process to another. And the only way, quite strictly, that you can go from one call to the other is through interface messages. There are actually other ways that they say. So typically, I'm reading these off the screen ahead of me. So we've got communication can be through sockets. You can do it through other sorts of operating system level messaging queues, or operating system level things like message queues, event systems, or it's called PubSub, publish, or PubSub for publish and subscribe, and things called mailboxes, which I don't know what they are, and I'm not sure it's incredibly important because clearly they don't get used that much. But those are the ways that things can happen. So if I was to talk about two things that happen in different processes, we might talk about, again, I'm really hot on MongoDB right these days because I'm using it so much. So, but it could just as easily be a SQL Server or Postgres or something. But you've got your web application running locally, and then you fire up a MongoDB process on the same machine, and your web app cannot access the memory of Mongo directly, but it can use that published API to make calls into the system of the MongoDB. And that's sort of what we're talking about, multi-process systems. And important to note that our programs that we write can do these things in other processes as well. The cost for the computational and, sorry, my mic I hope is still in a good place. The computational and latency cost to your system of going from completely self-contained in a single process to multiple processes is said to be higher, and it makes a lot of sense that it would be. So that's one consideration of why you would want to wait to go to multiple processes. And the goal of building it this way is to protect your lower level components from higher level ones. I don't think my MongoDB answer or my MongoDB example sort of answers that, but it's similar. We've seen the images earlier tonight. And the lower level system components are considered to be the ones that are more important, or they are the things that matter. By way of things that matter, we again go back to the business rules. I'm gonna, you know what? I'm not as comfortable just waving my hand away and saying we're not going to define business rules. So I'm going to jump ahead to chapter 19 and just read out the bit that we're talking about. So business rules are effectively also known as policies, and policies are said to be, where is it? Right here. Policies are said to be the things that matter to your business such that your business makes more money, so turns more profit, or saves more money, right? So, in most non-trivial policies, many describe. Is this good content? I'm reading a book while you watch me move my lips gently. But anyways, so policies are said to be things that make your company money or save your company money, right? They are the policies are the drivers of profit. Now, that's also to say that, and the author goes so far as to say that policies are, here it is. Here's the page. Policies are the things that would make or save your company money, even if they were executed manually. Anyways, even if they were executed manually, I guess assuming you could get somebody to work for cheap enough, to work as cheap as a computer in some of these cases. But anyways, it's that's the story. A a a Anyways, that's enough to sort of, I think. Hopefully, is that clear? Okay. Anyways, doesn't matter. Well, I mean, it matters for education, but like, I hope I did a good job there. Anyways, now the last level of isolation, of boundary isolation, is called a service. And typically in modern times, we think of services in the context of network services. So that's the case where it's quite obvious if it's running on an entirely different computer and we are sending our information over a wireless network. Of course, we're going to have increased latency. Of course, we are not going to have direct memory access to this system that we're talking to over there. And just, of course, that is a much stronger separation. Of course, the service is potentially developed separately. Of course, it is absolutely deployed separately. And of course, it is slower because we are incurring all of these costs about it. One of the things to note is this is said to be true, at least in this book, of operating system services too. So it's anyways, so it isn't just web services or network services that we're worried about in terms of this strongest boundary but highest latency. It's also stuff that we're writing on our own operating systems. So there's that. Now, most systems, and so now we're here at the conclusions. We're just going to wrap this up, and that'll be the week. So most systems, other than the monolith, uses multiple boundary strategies. So I suppose the monolith is said to only use one strategy where it's all in one thing, all glommed together. Cool. So local boundaries, because of their ultra low latency, are a really good choice for very chatty systems where information goes back and forth between the two items really quickly. Ooh. Isn't that wild? Sorry, I'm not even high and I'm doing that and I'm enjoying it. So, anyways, now next we've got services, and then finally, so local boundaries. We've got. I guess I did not summarize processes. Anyways, services, either local or network services, are more ideally chosen for operations that are less worried about latency or designed with latency in mind. So that's the week. Those are the two chapters that we have to worry about. Thank you for coming along. Thank you, Brooklyn, for stopping by and saying hello. It was nice to see you, virtual see you. What do we call that? Anyways, it was nice to hear from you. And that's the week.